Okay, so here's a very similar problem to homework problem number 1 in your homework. And it's asking us within what interval will 95% of the sample means fall. Now the book gives you a lot more details about the why behind this stuff. I'm doing here just, for this homework help, I'm just doing a real basic breakdown for you. But of course the book has a lot more information. So per the book, in order to answer a question like this, I'm going to use a concept that I'm refer here as confidence. And in this case, 95% confidence, and I got the 95% confidence level here from the problem, means that my level of uncertainty is going to be 0.05. And if you think about it, that makes perfect sense, because 0.05 as a percent is, of course, 5%. So that is very reasonable to see why that 5% level of uncertainty, that 5% alpha, is what goes along with that 95% level of confidence. Other confidence levels you might need, big hint later on when you're doing your homework problem. So a 90% confidence would translate to an alpha level of 0.1, because that 10% level of uncertainty would go with that 90% level of confidence. And 98% level of confidence would have an alpha level of 0.02. So hint, hint, some things that you may need. So we are going to first find the margin of error. And we're going to calculate the margin of error using our old buddy, our good old pal, Excel. And you're going to use this formula, which you can just copy and paste from the written notes right into Excel. Remember that Google Sheets works just as well as regular Excel also. So you're going to take this formula and you're going to copy and paste it right in. So let's take a look at where these pieces of the formula come from. So the first thing we need is our alpha level. So in the case of my particular example here, our alpha level that we needed is going to be 0.05. And again, I got that because a 95% level of confidence means I'll have a 5% level of uncertainty. The next piece of information that we need is the standard deviation, which I got from the problem right here. And finally, we need the number of values, our n, in the formula, which in this case is 35, and we got that from the 35 samples. So all we did is I'm going to now copy and paste that information in Excel. I gave you a little screenshot here to show you exactly what it looks like when you type it in there. And the output that I'm looking for is my margin of error, which is right here. And we typically round it to 4 decimal places, so that means that I'd be rounding to here. Now, because that number next to the 9 is an 8, which is a 5 or bigger, that means that 9 is going to round up, which also means that that 1 is going to round up. So the rounded version would be 0.002. Okay, so now we've calculated that margin of error using Excel. So we just did this part. So in order to figure out what the confidence interval is, you have to take the mean. So in that case, our mean was 0.9480, and that was given to us in the problem. And this plus minus that you often see in stats books means we need to figure out the higher end of your interval is going to be the mean plus the margin of error we just found in that first step. And then the lower end of your interval is going to be the mean minus that margin of error. So in other words, I need to do 0.94, so 0.9480, and I need to add that margin of error first. And that's going to be the upper level of my confidence interval. And then I need to take that mean again, and this time subtract out that error. So this will be the lower end of my interval. So I did that adding. So thus, my final answer that I would type into my homework problem is that 95% of the sample will fall in this range. It will fall between this value and this value. Part B of the same question asks us, what is the distribution? And I took a little screenshot out of the textbook that kind of gives you a little bit of important information. And what I really want to highlight here is when the number is greater than 30, that's a good rule of thumb that you've heard that is required to ensure a normal distribution. So when the number that you have is greater than or equal to 30. And again, that comes straight out of the textbook. So again, goes straight from the textbook, because that sample size is greater than 30, because we had 35, then we know that our distribution is going to approach normal, which means it'll be a bell-shaped with a mean of 0.9460, which is given to me in the problem, and a standard deviation of, these numbers should look familiar to you, right? That's the standard deviation that I was given above. Okay, so right here, that standard deviation, that 0.0060 that I was given in the problem, that's where it came from. Okay, so we take the standard deviation in the numerator and we divide it by the square root of n. Finally, part C asks us which theorem you use for that. I'm just going to highlight again a very important part of the book that you might want to take a look at. And that's all for problem number 1.